I'm Tim Ventura, and we're joined today by Dr. Kevin Knuth, a professor of physics at the University of Albany with over 2 decades of experience in machine learning algorithms for astrophysics, Bayesian probability theory, information theory, robotics, signal processing, neuroscience, nonlinear dynamics, quantum mechanics, and many other areas. Kevin is the editor of the peer-review open access journal Entropy, as well as being a member of the Scientific Coalition for UAP Studies and co-investigator on a NASA-funded grant to study exoplanets. In September 2019, Kevin published the landmark paper estimating the flight characteristics of anomalous unidentified aerial vehicles, co-authored with Robert M. Powell and Peter Reali. In that paper, he described UAPs as reportedly being structured craft that exhibit impossible flight characteristics. He joins us today to discuss his continuing research into the UAP phenomena, along with new work modeling the characteristics of ET civilizations for first contact scenarios. So, Kevin, welcome back, sir. It is a pleasure and an honor to have you with me today.
Wow, thank you so much for your kind introduction, and thank you for having me. This is great to be here.
Oh, absolutely. So
I'm also, I don't know if it was mentioned, I'm also the lead scientist of UAPX.
Oh, thank you. Thank you for adding that.
I didn't realize, I didn't catch all of that, so I wanted to make sure that was mentioned. Great, so thank you.
Today, we are talking about UAP and ET civilizations, both of which are making headlines right now. So former intelligence officer David Grush and Senator Marco Rubio are talking about recovered spacecraft. House Representative Tim Burchett has a hearing scheduled for July 26th. And last week, Senator Chuck Schumer, along with a group of 5 other senators, introduced legislation suggesting that the U.S. government or private contractors may secretly possess recovered UFOs and biological evidence of living or deceased non-human intelligence. What's your take on all of this?
Are we really surprised? In some sense, these claims have been going on since 1947. Since Roswell. And yeah, we can all chuckle about that, but something extraordinary happened at Roswell, and we never got a clear story from the Air Force or Army or anybody. The first news report that came out says that it was a crashed flying saucer, and they rapidly moved to discredit their own article on that and their own story, and then over the last 5 decades, produced like 5 other stories, Project Mogul, and we've got these balloons looking for atomic, bomb testing in Russia, but they have plastic mannequins on them and stuff. I mean, none of it makes any sense. And when you see a group like this that's been secretive and have been covering things up, clearly not being forthcoming, what story do you believe? You believe the first one. The first story was probably the real one, and that's how I've always felt about it. They probably found a crashed flying saucer. I think that that's probably reasonable, and that's why they moved so fast to cover that up, and that's why they threatened the lives of witnesses and so on. So and David Grush is here, and he's now saying similar things, not necessarily about Roswell, but that we have crashed craft and biological materials, that he's heard about programs like this and knows people who work on them. And he's had people in the government retaliate against him, and he's had threats to his own life. And so, I mean, this is the same story that's been going on for 80 years that everybody chuckles and giggles about, that won't go away, frankly, and is clearly very serious now that the U.S. Navy has to encounter these objects in some cases, at least in 2015, it was almost on a daily basis. These are real objects. They are not understood. And the fact that we have refused to even look at the problem means that we are completely ignorant about it, which is never the state you want to be in, especially when you have a problem. So I think it's serious. It's dead serious. And I applaud Schumer and Gillibrand and Rubio and Burchett and all of these people for taking the actions they have, because it's important, and it's important that we, the public, know what's going on. You know, as citizens of this country, we should know what our government's up to. As citizens of the planet, if there's somebody else here, we should know about it. That's important.
Yeah, yeah.
And I think there's other moral questions that don't get raised and haven't been raised yet, which is probably one of the reasons why this gets covered up. Because if we've been trying to shoot these things down, that's an act of war. And do we really want to take that path with an adversary that we know nothing about? And if those actions have been taken, who authorized that and why? And was that even legal? That's a big problem. If there were craft recovered, especially ones that were shut down, and there were biological entities captured, what happened to them? Were they returned home? Did we make arrangements with the place they come from to have them returned? Did we just keep them prisoner? Did we torture them with vivisection? I mean, God only knows what happened. You know, this is all covered up, but these are important moral questions. And had we done this to a Russian, it would have been a big problem. And the fact that this might have been done to an unknown adversary, maybe not an adversary, but an unknown actor is really a big problem. It's serious.
Well, so you have carefully studied the UAP phenomena for several years now from a dispassionate scientific perspective. So I was surprised last week to see an abstract that you're publishing for an upcoming paper aptly titled Evidence Suggesting that Some UAPs Are Advanced Non-Human Craft. Do we finally have enough evidence to conclude that UAP are extraterrestrial?
I think we've been able to make that conclusion since the 1950s. Herman Oberth, rocketry pioneer, he gave a talk on UFOs in 1954 where he basically made the same suggestions. He discussed the fact that these craft can travel at speeds through air up to something like Mach 45. You're talking 35,000 to 50,000 miles an hour in air with no sonic booms. And he knew this, and he mentioned in his talk in 1954 that that there were over 50 radar reports of this at the time. So, and he also mentioned extreme accelerations. He didn't give any numbers. He mentioned he described how the astronaut, whoever was flying it, would be pressed against the wall and unable to move, and maybe injure themselves. The accelerations we've estimated now are far beyond that. You'd be a puddle of jelly on the floor, coating the equipment if this were the case. So this has again been known by some who've paid attention for a long time. What I've done in the last few years is I've gone through as much information as I can get. Yes, some of it's historical data, and you have to handle that carefully because it's not scientific data. But you can place uncertainties on things and take that into account. Just because I'm a scientist doesn't mean I can only learn from scientific data. I'm not that restricted. I'm smart enough to be able to learn from pretty much anything. And I think that my fellow scientists are too if they applied themselves. So yes, we've so for one instance, we've looked at in my paper with Robert Powell and Peter Reali that you mentioned, we looked at several cases where we estimated speeds and accelerations. Speeds getting up to 45,000 miles an hour and accelerations up to about 6,000 Gs. So this is extreme. 45, to put this in perspective, 45,000 miles an hour is how fast the New Horizons probe that flew past Pluto in 2015 is going. So these craft are these things. Yeah, you want to call it a natural phenomenon, be my guest, but I don't know any natural phenomena that can accelerate at 6,000 Gs and barrel through the air at 45,000 miles an hour. So, But that's not the only evidence. And this is one of the things that I've been doing to try to firm this up. The idea really isn't to prove the hypothesis, it's to rule out the other hypotheses. What data can we get to rule out that this is some of these are natural phenomena? Some of these are natural phenomena. Not all UFOs are alien spacecraft, of course. No one would make that claim. But some of these things definitely appear to be non-human tech. The electric fields that are produced by these objects are extremely high. You can estimate these based on reports of car engines shutting down. And more than that, car engines shutting down and restarting when the UFO leaves. We actually, I think it was McCampbell had done some work to hypothesize how this happens, and I reworked that in this paper and show that yes, you get the right percentage of cases. I don't remember what the numbers are off the top of my head, but it's something between 10 to 20% of the cases of gasoline powered cars will restart after the UFO leaves and has shut it down. And the model that explains why this happens predicts that number. So witnesses did not all conspire to, okay, we're all going to pretend over decades that UFO flew over and shut down our car, and then some of us are going to say it started up again. We're going to have to make sure that the number of us that say that happens falls within that percentage range. Nobody did that. That's not possible. You'd have to believe in crazier conspiracy theories if you're going to believe that. And it's interesting because it's once you understand the mechanics, once you see that model, you realize, yeah, this makes sense. Basically, the electric field around the UFO is so powerful, it's ionizing the air. So you're talking about, 3 times 10 to the 6 volts per meter. This is a huge electric field. And so you've got ionized air around the spark plugs of your car. So the electric current isn't going to go through your spark plug. It's basically going to short out. So your car stops running. And then if you keep in mind how a car works, basically you've got a distributor cap that spins around with switches that are basically going to send signals to each of the spark plugs. But ultimately, first that goes through a transformer, right? Because you have to up the voltage. So you go to a transformer, which then has some output. So now the spark plugs are, with the UFO there, you've got this high electric field, you're shorting out the spark plug, so the engine isn't running. But the switches in the distributor cap are the one that it's oriented toward is also shorted out. So you've got current flowing through the primary of this transformer. So you've got this magnetic field sitting in the primary of this transformer, and nothing's happening. So now the UFO leaves, the electric field disappears with the UFO takes it with it. So the air is no longer ionized. The current stops flowing in through the primary, but that means the magnetic field collapses in the primary, which induces a magnetic field in the secondary and gives you a voltage pulse to the spark plug. And that certain percentage of the time, the engine is in the right position so that when the spark plug fires, the piston will go and it'll start the car.
Okay.
So you can reason why this happens. And I always thought, you see this kind of happen in Close Encounters of the Third Kind, right? With Richard Dreyfuss and his truck, and Spielberg plays that out pretty well. But it always appeared magical to me, like the UFO makes the car shut down and then it leaves and the car just turns on again. It seems magical, but there's nothing magical about it. It's just physics and the electronics of how the car works. Yeah. Once you realize, then the whole thing makes sense. And you're like, oh yeah, this is very sensible. But what that means is that the electric fields around these craft are huge. You can also estimate the magnetic fields around the craft. People have taken photographs of these where you can see what are called Faraday rings, which are interference patterns, which are basically coming from the polarized light from the sky. The light in the sky is mostly polarized about 90 degrees away from the sun. So some of the light coming from the sky is polarized. Magnetic field basically is going to rotate the axis of polarization, so that the electromagnetic wave is coming in, but then it hits the magnetic field and it actually rotates. And then if you take a picture of this object with a polarized lens on it, you're going to block out some of this light depending on how much it's rotated. And so this actually can tell you about the structure of the magnetic field around the object. So you can actually learn a lot about the magnetic fields of these things by looking at these imagery. And the first calculation to do is the calculation, and then this is one thing that frustrates me when I see physicists, who are super skeptical about this, because they haven't even done the first calculation. The first calculation is, how strong does the magnetic field have to be able to produce the Faraday effect in the air, at some distance? And it's crazy strong. It's something like 10 to the 11th to 10 to the 15th amp meters squared would be the magnetic dipole moment. So this is a huge, huge, huge magnetic field. Totally not physical. It's not a natural occurrence. This does not happen in nature. These are clearly highly advanced machines. And then dealing with the speeds and accelerations, you can put bounds on the power it takes to do these maneuvers. And so in those cases, you get amounts of power on the order of hundreds of gigawatts of power. The amount of power more than, at least in the Nimitz case, when the Tic Tac dropped from 26,000 feet to sea level and stopped, that maneuver there took about 1,000 gigawatts, which is more power than the United States puts out in nuclear power, total. That one little craft, 40 feet long, this put out as much, would have had to have exhibited that much power, which is unimaginable. But then people like Jacques Vallée also have, and Bruce Maccabee have done studies where they've estimated the luminosity of these things. And this one surprised me because I did not expect the power of the luminosity to be so high. But when you do these calculations as well, you get estimates on the order of, again, tens of, gigawatts of power, hundreds of megawatts, gigawatts of power in illumination, just the light coming off of this. And it was enough to make me stop and think, who the heck would put out a light that bright? Why would you need to do anything like that? In one case, you had a landing in Arkansas, was witnessed by a physicist driving down the highway. He saw the object mile ahead or so in the forest clearing, could see the light coming from it, and thought, that's a crazy bright light, and did the calculation in his head, just estimating the brightness of comparing it to the brightnesses of his headlights. Realized that this thing was putting out megawatts of power of light, and stopped the car and turned around and left because he said, I don't want to be anywhere near this thing. And Jacques Vallée went and studied the area, went and found the clearing where it landed, and the trees were charred. The trees around the clearing were charred. They weren't burnt, but they were charred from the optical illumination. The other side of the trees weren't charred. And they actually collected that material, and as far as I understand, they're studying this now. So I don't want to get any details. This is his work, but so who has a machine that puts out megawatts of light illumination? And if they're not using it to illuminate things, then it seems like it probably would be waste energy, right? But then if your machinery is so inefficient that you're losing megawatts of power to waste energy, then that's a little scary, because it means that megawatts of power aren't a big deal to these guys, right? So these things are exceptional, and the paper is going to go into lots of detail about how they're exceptional and anomalous. They're anomalous in many, many ways, and we have many pieces of data from many observations around the world for decades, and it's pretty inescapable.
Well, so up until now, the UAP narrative has been about the observations and evidence here on Earth. But you recently took this into the realm of space science, which I absolutely applaud. I think that's the next step beyond this, with a Max Ent 2023 conference presentation at the Max Planck Institute, where you presented a model reminiscent of the Drake equation that simulates the characteristics of ET civilizations for first contact scenarios. So I'm wondering, can you give me kind of an overview of the presentation's goals and how you approached modeling this?
Sure. Yeah. First, let me stress that the evidence that we have so far is that this is non-human tech. We don't necessarily know that they're extraterrestrials. We don't know anything about. I don't think anybody knows anything about the details of who these peoples are, where these craft come from. So it's often been it's been recognized by numerous physicists throughout the years that interstellar travel would be possible at relativistic speeds where time slows down, right? And you can kind of bypass the large amounts of time that it takes to traverse these enormous distances this way. But the argument has always been, yeah, but who would do that? Who would bother to do that, right? And so I always thought, well, that's really a pretty lame argument. We bother to do all sorts of crazy things that we do because we're curious. And I can imagine somebody more curious than we are would certainly do things like this. So the first thing that you need to do is to get your expectations in order. It's easy to just kind of sit back with your beer and think about what you imagine interstellar travel might be like, and then just argue that, yeah, it's probably impossible, right? That's what most people do. Well, let's actually do some simulations and see how possible it is. Let's see if we can do that. So what I intended to do for this project was to simulate many civilizations. I ended up simulating 1 million of them. And these are all interstellar or spacefaring civilizations. So they're capable of space travel of some sort. And I thought that if I could model interstellar colonization, I could then keep track of which ones happen to find Earth. And then, based on the fact that I've got this ensemble of 1 million possible civilizations and only some fraction of these guys find Earth, now I can take that fraction and look at the statistics and find out what it takes to find Earth, right? What do you need to? What do your capabilities have to be able to find Earth, or what does the situation have to be? So I found that, what was it? Something like 1.7% of the interstellar civilizations that are actively colonizing end up finding Earth. It's a very small percentage.
Yeah. So actually, if I could jump in, I took notes on your presentation.
Oh, thank you.
Yeah. So across a wide range of input values, you arrived at some interesting conclusions. Out of 10,000 sample civilizations colonizing the galaxy, you calculated that only about 1.7% of them find Earth. The average domain radius for each civilization is around 6,000 light years in diameter, and the homeworld for anyone who arrives here is between 6,500 and 20,000 light years. And then you had also said that these civilizations are likely to be millions of years old, and if Earth is found, it implies that there are over 100 spacefaring civilizations in the galaxy, and they would have arrived here most likely around 375,000 years ago.
Yeah, that's basically it. Yeah. So the models. I mean, the first problem is how do you begin to model a civilization that, when you've only grown up knowing one, right? And so how do you do this and do this well? You can't possibly model the diversity that exists out there. So you can imagine biological civilizations, and you can imagine civilizations of artificial creatures that were created by biological organisms that then form their own civilizations. So some of these things could be autonomous autonomous with agency, right? So we don't know what the situation is. So I had to model things with just a few parameters. That's the idea. So you have a simple parameter. One of them I called the resiliency, which is what's the probability that members of the civilization would find a planet or a moon to colonize in a given star system. And I just use a number there between 0 and 1. So if you need a planet that has, that's doesn't get below 60 degrees and doesn't get above 80 degrees, and it's always sunny and by an ocean or something, then, like maybe Southern California, then you're out of luck. Your resiliency is going to be really small, right? It's something like 0.01%. So you would have a small resiliency. You're not going to go very far because you're not going to find a nearby planet like this. However, what do you mean by colonization? I also don't specify that. So that kind of goes into the resiliency number. By a civilization, you could just mean terraforming a planet or exoforming a planet and actually putting a population of creatures there. Or it could mean something simpler as just setting up an orbiting space station, or scientific monitoring stations or something like this. So it could be something rather simple. And then the main things to model are what are their space traveling capabilities? How fast can their ships go? How fast can they accelerate? How long are they able to spend in their spacecraft? So biological organisms with a lifetime of 60 years, they're probably not going to want to hang out in spacecraft more than 10 years. So that puts huge constraints on what you can do. If you're an artificial organism that can live for 20,000 years, then that's a whole different ballgame. And
if I could jump in, actually, this is one aspect of your presentation that did confuse me a bit. So all of the transit velocities that you talked about were sublight, but even at those relativistic speeds, and this is something you described in the presentation, the radiation would penetrate traditional shielding. So there's that aspect of it. There's another aspect, which is video evidence such as the Agua Dia encounter could suggest gravitational lensing, which hints at warp drive, wormhole, or some kind of faster than light capabilities. So one of the things I was wondering about was, again, in the presentation, everything you talked about was sublight, and that carries with it a lot of radiation issues for any kind of passengers.
Right.
But we may be dealing with some kind of organisms or entities that can travel faster than light, or just basically
use
go around
wormholes
that
to bypass things altogether. And exactly,
Yeah.
no, that's definitely true. Or those are definite possibilities. The problem that you run into is that we don't know enough about any of these exotic forms of travel that I'll call them that we don't know enough about them to be able to model the physics of how it would work. Yeah. Right. Yeah, we know that there are people working on different types of warp drives or using metamaterials and changing the speed of light and things to accelerate your craft, go faster than light possibly. Yes, you know that, but we don't know how fast a craft could actually go and what the physical constraints would be. So I couldn't model that. And that's one of the difficulties. So this work really is that you can really only make predictions about things that you really understand well. And you're kind of stuck with that, right? So the situation would be very different if you could have things like warp drives and faster than light travel. So that would change the behavior quite a bit. So that's something that you might be able to model in various ways without going into details that would cause problems, but it's something I'll have to think about. But this was kind of the first pass. Describe what you know, figure out based on known physics or traditional known physics and then figure out what predictions you would make from that. And that's basically what this paper was aiming to do.
What interested me, I think, the most was so again, I should put this out there for the audience that all of these this is a probabilistic examination of things, much like the Drake equation. So again, you ran many simulations with different parameters, right? Just regular software.
Yeah, just pulling random parameters. So you basically have random civilizations with random capabilities, and then you see which ones can find Earth. Yeah.
Yep. And then that groups out into probability ranges. So you have these bracketed probabilities. And the thing that I think was one of the things that was very interesting to me was this idea that if ET has arrived, they arrived again 375,000 years ago, which echoes something that I have been seeing more and more lately, that if something is here, it has been here for
They've been here a long time. Yes. Yeah, and here's the way to reason it. You can work through all the probabilities and you can work through the samples and show that this is definitely has to be the case. If so, the idea is if you detect somebody here today, then these models would suggest that members of their society or civilization have known about Earth and been visiting Earth for more than 250,000 years. A long time throughout human history.
Yeah.
Now, there's another way to think about this, and that you could arrive at the same conclusion, is that let's say that you have let's say that it takes about 1 million years for a civilization to colonize planets and to expand some domain. And let's say that they happen to find Earth, right? When during that 1 million years of their entire existence would you expect them to have found Earth? On average, it's going to be at the halfway point, right? So if it takes about 1 million years to create a galactic colonization effort, and sometime during that 1 million years you happen to find Earth, it didn't happen yesterday. The probability that it happened in the last year out of that 1 million year epoch is 1 out of 1 million. It's not probable. And that didn't happen the first year either. It probably happened somewhere in the middle. So, and when you do these simulations to find out how long it takes to do these, to perform these colonization efforts, you find that midpoint ends up being, for finding Earth ends up being on the order of 375,000 years.
So this seems to put us further into the zoo hypothesis then, which is that ET is likely here studying humanity the same way that we would go into, the rainforest to study the life forms there. And presumably, if an F-16 shoots down a UFO, that would be the same thing as a tiger eating an explorer in the jungle, right? Where it's not an outcome that anyone wants to happen, but at the same time, it's kind of an assumed risk. That's kind of my thought process.
Yeah.
Yeah.
That's very possible. The other the other findings that you've noted is that their entire domain is on the order of 6,500 to 20,000 light years in diameter. So they are occupying star systems within that large sphere, and that puts us well within their domain. We are very probably well within their domain, which means that they have some presence here on Earth, but pretty much all the stars that you see in the sky in the area, well, not all of them, but with the nearby ones, Vega, what's Vega, 20 light years away or something, they probably are active there too. Alpha Centauri, they're probably active there too. These are all star systems that they could very well claim to be their own and part of their domain, which puts us in a really interesting situation, right? If it's basically the whole colonization problem all over again. but this time all of humanity is on the business end of it.
Well, so one thing I should ask is whether you think that these are biological organisms, as again David Grush has alluded to, or if they're robotic. And one of the reasons that I wanted to get into that, there are many reasons, but I'm very partial to the idea of von Neumann probes. And part of that is because of the replication process, right? And so, again, from even assuming you could travel instantly from one star to another, like a wormhole or Stargate or something like that, it still takes time to explore each planet. And if you really want to explore the galaxy, it seems like the best way to do that is to use something that takes advantage of natural, exponential doubling, right? So the thing that I love about the von Neumann probe idea is you were able to launch a small number of those, they create more of them, and then they robotically explore the same way that we have robots exploring virtually all of the planets in the solar system right now, right? We have probes flying by all the major planets. We have robots on Mars. All of that is conducted mechanically, and then it reports back findings to Earth. So it would be similar to that, except that these would be potentially capable of making more copies of themselves to explore more planets. So do you think that we may be seeing something like that with the Tic Tac?
It's possible. I mean, it's certainly that the von Neumann probe idea of self-replicating probes is certainly probably the most efficient idea. It's the most efficient in terms of exploration and energy usage and effort on our part, or the creator's part. So it's a great idea. I'd be surprised if nobody has ever tried it. Nobody in the galaxy has ever tried it. That would shock me. We're looking into trying it already. I mean, I know of at least one research effort that's looking into designing von Neumann probes. So we're already looking into this, and we've been flying for 100 years only, right? So I think this is probably, this is a likely scenario that many of these things are robotic. That doesn't mean that all of them are, and we don't know how many, if there are civilizations who know about Earth or have been visiting Earth, we don't know how many there are or how many have been. So there could be a diverse set of
Yeah. Well, and I realized that I've inadvertently stumbled into rampant speculation. But
Yeah.
the reason that I wanted to mention that, though, was, and this goes back to a conversation you and I had a couple weeks ago. You had said that if these, again, if we're dealing with self-replicating probes of some kind, one of the best places for them to replicate is in the ocean, where they can pull all sorts of rare elements out of the seawater where everything is dissolved, right? And so
Right.
instead of having to have a mining operation per se, like we do here on Earth to build things, you could literally have basically nanotech factories, self-replicating. The best place to do that would be right around where the Nimitz sightings are, right? In the ocean.
Yeah, you just drop into the ocean and you have dissolved minerals and elements there that you could take advantage of if you had that technology. That would be a great idea. And that may be one reason why some UFOs are associated with water, as you're suggesting. That's very possible. But
Yeah.
But again, these are really, we're speculating here, but each of these are really some kind of hypothesis that you could eventually, with more data, you could work to rule out some hypotheses or find support for others. Yeah.
Absolutely. Well, and again, one of the things that excited me so much about your presentation was you're finally connecting the dots between what is being observed here on Earth and the assumptions that we're making about these and space science, right? And there is, I mean, close to a century of work, and a lot of it speculative, but scientific work being done in space science. If we're able to bring those things together, maybe we can learn more about both aspects of this, I guess.
Yeah, I think that's right. I mean, this project, basically, the idea of this project was to move away from just speculation and even back of the envelope thinking with a beer to let's actually try this and through simulation and see what works. The other benefit to this, even if you are uncomfortable with the whole extraterrestrial business, is that this also gives you some kind of measure of what it would take for us to undertake a colonization, interstellar colonization. Would we be capable? We now have some of the statistics. You could see that, right now we estimate we probably could get ships up to 20% the speed of light if we really worked at it, right? So you find that, yes, there are civilizations that perform colonization and find Earth going only 20% the speed of light. That's possible. But then what is it going to take to do that? Are we going to have to sit in our spaceships for 500 years? Are these going to have to be generational ships? Or these are the things that you can then look at the statistics and get some idea of what's possible that way.
Yeah. Well, and again, in the realm of speculation, one of the other ideas I wanted to put out there, and this comes from a book called The Light of Other Days by Stephen Baxter and Arthur C. Clarke, but they got into this concept of you don't necessarily have to send matter across the galaxy. You just have to send information, right? And we're starting to see hints of this today. I mean, Eric Drexler and others have talked about advanced nanotechnology, being able to synthesize all sorts of materials. Again, if we're dealing with von Neumann probes, that would be inherently a part of what they can do is synthesize from basic elements and build things up. In our own technology, we're seeing hints of this through 3D printing, right? Where you send information across the internet and you use common materials to create novel products. So one of the other ideas could be that they may not necessarily be sending pilots or sending fleets of craft or who knows what across the galaxy at all. Maybe all they have to send is one and they can build the others when they arrive wherever they're going.
Oh, that's interesting. Yeah. There's a lot of interesting things to speculate about, and it's worthwhile because this is a big galaxy and we really have no idea what's out there. It's easy to look at the few planets in our solar system and see these as dead worlds and think, well, there's probably nothing anywhere else. But then you're ignoring this one, which is really pretty spectacular. So it's very possible that there are some really amazing places out there with some really amazing beings and some amazing ideas and amazing efforts.
Yeah. And so one of the takeaways that I've had, and I could be mistaken, but for my interpretation of, again, your presentation, as well as I did a recent interview with Robert Zubrin, where he discussed the Drake equation and just various things I've been looking at is if these probabilistic equations are anywhere close to accurate, it sounds like the galaxy is full of primitive life and probably full of ancient ruins of civilizations that have come and gone. And then it also has a number of active civilizations. Ours would be one of those. And my assumption would be that they would, again, going to the zoo hypothesis, those would probably be treated like rare gems, because there are so few of them comparatively that are active. So.
Yeah, that's interesting. I was fortunate to see a talk by Robert Zubrin when I was at NASA back in the early 2000s, and he gave a talk on panspermia, which was fantastic and really, really interesting. It was not, again, he worked some of the numbers, which is what you have to do to take these ideas, right, and put your knowledge of physics and science to work and see how reasonable are some of these ideas. And that's what he did in that talk. And I walked away thinking, wow, the panspermia is a really reasonable thing. This is a sensible thing. And since then, probably it was around that time, we now have some information that you can have organisms, even multicellular organisms, can survive reentry and crash landing on Earth. We know this. We know this, sadly, because of the Columbia disaster, the space shuttle Columbia, which burned up upon reentry and then crashed across the southern United States. There was an experiment with nematodes, which are like roundworms, that were kept in a canister in a fortified locker just to keep them safe on board the space station, or on board the space shuttle and coming back. They were put in this locker. And those roundworm experiments were recovered, and the hundreds of roundworms survived reentry.
Okay.
They survived coming into the atmosphere at 17,000 miles an hour, everything burning up around them, and then crashing, on the ground. But the hundreds of these worms survived. So the idea that you could have bacteria in rocks, that if the rock can survive reentry and the internal parts of the rock don't get heat shocked, then the bacteria can survive. Yes, that's very possible. We know this because we've observed this.
Well,
so now we have, in addition to this theoretical idea that Zubrin had, we have a data point, and it's a very strong data point, because these aren't just bacteria that survived; these are multicellular organisms that survived.
Yeah.
So that's a big difference, and it shows how possible this really is. So, and then Zubrin points out that if you have rocks that have been blown off the Earth that have bacteria in them, and they've been in space for a long period of time and they're frozen, if they can survive for millions of years, every 20 million years or so, you get stars passing close enough to each other that the material from the Oort clouds gets transferred. They exchange material from the Oort clouds. So Earth rock could have been, lifespan on Earth for 4 billion years or so, more than 4 billion years. So for those 4 billion years, Earth rocks with bacteria in them could have been infecting other star systems.
Yeah.
And if you do the math, you end up with, thousands of star systems that have probably been infected with Earth bacteria, which is amazing, right? So it could very well be that all the life we end up finding in the star systems around Earth are all related to Earth, and that could very well be the case. And it could also be the case that life on Earth did not originate here.
Yeah, so there's an idea called comet swapping, I believe, or I think that was it, and I think that's related to Zubrin's Oort cloud. But then I read an article online saying that potentially these comets don't necessarily have to just go from one system to another. They could potentially go towards the galactic core, and so you could have panspermia all over the galaxy. But I also wanted to mention a 2018 paper that goes directly to the nematode experiment. This was entitled Cause of the Cambrian Explosion, Terrestrial or Cosmic, and it was published by a group of 33 life scientists, all of them PhDs, who suggested that the modern octopus is the result of panspermia. And even though this idea may sound shocking to a lot of people, it's something that I guess has been discussed for quite a period of time in the life sciences. And part of that, I think, is just the octopus, the 8-arm layout of its body. It's very, very different than other animals, as well as the intelligence of the octopus is much higher than, anticipated, I guess.
Yeah, that's interesting. And it's not, so as far as I understand from that paper, they're not suggesting that octopus traveled here on a comet and were deposited. That's not what they're saying, which is easy to misunderstand that if you don't hear the whole story. From what I understood is that there was some kind of retrovirus that they were hypothesizing had been transferred.
Okay.
So that then affected evolution here on Earth or something. That's what I think they were hypothesizing. I would have a hard time believing that new life was deposited here that was different, because it would have to be different than previous life, right? So you would have to have that octopus are not at all related to any kind of bacteria, right? Which is certainly not the case. Yeah, I don't know exactly what they were claiming about and how octopi fit into the whole problem, but I'll have to go read that paper in some detail and see what they're saying.
Yeah. Well, and I have to plead
But
ignorance.
it's very possible that you could have life being deposited here on a regular basis and it affecting things. That's very possible. But we haven't found any forms of life that aren't related to the forms that are already here. So that's an interesting fact that would suggest that maybe panspermia isn't happening, or at least if something is transferred here, it doesn't gain a foothold. But then, as Zubrin points out, we also don't have remnants of anything simpler but then bacteria. So we don't have any evidence of how bacteria ever evolved in the first place. And that is suggestive of panspermia, and I would have to agree with that.
Well, Kevin, on that note, let me thank you so much for your time today. We have truly taken a jaunt. I mean, we started with UAP, we went into alien travel and faster than light, and we ended up with space traveling octopi. So I think that's probably enough for one day. We've probably blown quite a few
enough for
minds.
anybody. That's right.
Yeah, that's but I think one of the takeaways of this is UAP, the UAP phenomena. For me, this is where it begins, not where it ends. And I think that hopefully the audience can keep in mind that the universe is larger and more complex than probably any of us imagine or are capable of imagining, and that's a wonderful thing for exploration, right? And that's what we do as human beings.
We have a lot to learn, a lot, and becoming aware that UAP are real things, and if it really does pan out that some of these are non-human tech, there are so many discoveries to be made. I know there are people who have in their minds that, oh, if I can prove UAP are real, I could get a Nobel Prize. And like, no, there's like tons of Nobel Prizes here. Not that a Nobel Prize matters, but in the sense that there are so many discoveries to be made. How are they controlled? How would a craft like this control that amount of power and energy? Where's that energy and power coming from? How do you channel it? How do you perform those accelerations and not destroy everything in the ship? How do you do that? That does suggest something like gravity manipulation, right? So your suggestion about warp drives and faster than light and all this is suggested by these high accelerations, but we have a lot to learn, and it's very exciting. And I'm as you mentioned in the introduction, as I mentioned the other day, I'm now on a NASA-funded exoplanet project. And what I really came to terms with in putting that together with the PI, Michael Way, that we are just now starting to learn what the universe is actually like, which is exciting. I mean, this is an amazing time to be alive. We're just now starting to find out what the universe is like. And this idea that it's like our solar system is probably not correct. Our solar system is a bit different than other solar systems. And so how is it different? And how is that difference going to manifest itself in the diversity of other things that exist out there? It's very exciting.
Thank you so much for your time today, Kevin.
Thank you.